I will talk about probability density function. The probability density function or PDF describes the relative likelihood for a continuous random variable take on a particular value. It is usually denoted as fx and it usually satisfies the following properties. The, the first one is the non-negativity, which means that the value of fx should be greater than or equal to 0 for all x values. And the second property is the normalization, which states that the area of the under the curve of entire PDF is equal to 1, which means that if we integrate fx from minus infinity to infinity, it should be equal to 1. Unlike probability mass function, PDF does not give the probability at specific point, but rather the density of probability. The probability that a random variable falls within a certain interval AB is given by the integral of PDF over the intervals. One of the example of PDF is a normal distribution having mean mu and standard deviation sigma. In this case, the PDF can be expressed using this following expression. Now, I will talk about cumulative distribution function or CDF. CDF of the random variable provides the probability that the variable takes on a value less than or equal to a specific value. In other words, it gives the cumulative probability up to a certain point in the distribution, which means that it adds the older values and gives the new results. The CDF is useful for understanding the probability structure of a random variable. For a continuous random variable x with PDF fx, the CDF fx is defined as this. Okay, so there are some properties by which you can identify the CDF. The first property is that the range. The CDF ranges from 0 to 1. As the x approaches negative infinity, fx approaches 0, and as x approaches positive infinity, okay, fx approaches 1. The other property is that fx is non-decreasing function. That means it always increases with the value of x. The third property, it should satisfy this following limit. That means the limit, the fx should be equal to 0 when x tends to minus infinity and fx is equal to 1 when x tends to plus infinity. And the fourth one is the continuity. So if the function we have taken is a continuous, the CDF which we obtain is also a continuous function. Now let's talk about in terms of Python, how it can be plotted using Python. So these first four lines are used for loading the modules. So we are importing the SciPy, NumPy, Math.lib as pandas. Here, this line, mu is the mean and sigma is the standard deviation. We have taken mu to be 0 and sigma to be 2. This line generates 100 evenly spaced value ranging from mu minus 3 times sigma to mu plus 3 times sigma, which typically covers 99.7% of the data in the normal distribution. Y calculates the PDF at each point in X using stats.norm.pdf. While C calculates the CDF value at each point in X using stats.norm.cdf. Here n specifies the number of random samples to generate. Here in this case, this is 500. This line generates n random samples from the random distribution with mean mu and standard deviation sigma. This line creates the Panda data frame from the generated samples, and this prints a statistical summary of that data frame. Next lines are for plotting the figures. So this specifies the figure size. These are for plotting the subplots. We want to plot both PDF and CDF, so we are adding two subplots. This is for setting the title, and we are plotting the histogram using this command histplot. And then we plot the x and y values. Here in this case, this is for PDF. Similarly, we do the same for the cumulative distribution over here. So if we run both the cells, you will get the following output. You can see the normal distribution curve over at the left hand side and the cumulative distribution over the right hand side. So now let's verify the property of cumulative distribution. So as you can see that as the x values is increasing, the density value gets close to the value of 1, and when the x value gets close to minus infinity, the x value gets close to 0. So it satisfies the first condition. Also, it satisfies the third condition, which states that the value is equal to 0 when it approaches minus infinity, and the value is equal to 1 when it approaches the plus infinity. It also follows the second property as well. As you can see, as the x value is increasing, the value of fx is also increasing. So here it is also satisfying the second property. And since we are taking the normal distribution, which is a continuous function, you will also obtain the cumulative distribution also as a continuous function, which you can verify using their properties.